So in this video, we are going to be talking about finding the greatest common factor between multiple terms, both with numbers and variables. But before we start that and do a couple problems, I wanted to make sure we understood what the definition of the greatest common factor is. Remember, the greatest common factor is the largest number and or variable two or more terms have in common. And there are times when we can look at two numbers very easily and determine what their GCF. For example, if I want to look at the 15 and 25, it's very easy to see that my GCF here would be 5. That's the largest number that both 15 and 25 have in common. But sometimes it's a little bit harder, and what we're going to learn on this section is how to find that GCF no matter what numbers we're looking at or what variables are involved. So we're going to see our first example here in just a second. So for our first example, I want to find the GCF between these three numbers, 70, 20, and 30. And you might be able to do this without going through the steps, but I'm going to go ahead and work through the steps with you so that you understand how we can find the GCF no matter what numbers we're working with. So what I want to do is just write down my three numbers, 7, 20, and 30, and then I want to prime factor. Remember, prime factor is where we break a number down to his prime numbers. And one of the coolest things about prime factorization is it doesn't matter how you start the prime factorization, it is always unique to every number. Every number has a unique set of prime numbers that multiply to get that, so you can never really do prime factoring wrong. So I like to start, especially when I have something that ends in 0, with the easiest thing, which is 7 times 10. So 7 is a prime number, 10 is not. We're going to break down 10 to 2 and 5. Now, one of the biggest things you have to remember, especially with the type of prime factoring I'm doing here, which is called a factor tree, once you break up a number like 10, you no longer look at him as part of your factor tree. We only look at these, the 7, the 2, and the 5. We call those terminating ends. So what I like to do sometimes is just go ahead and cross out that 10, just to kind of remind myself that he's not part of my factor tree. So with 20, again, I could use the 10, so I could say 2 and 10, or I could say 4 and 5. Remember, you can do multiple different ways. As long as you go to prime numbers, you're going to get the same answer either way. So I'm going to go ahead with 2 and 10 again. And again, 10 is 2 and 5, and I can mark that 10 out so I don't pay attention to him since I've broken him down to 2 times 5. Same thing with 30. Let's do 5 and 6 with 30. And then 6 is 2 and 3. And again, I want to mark out that 6 because I've already broken him down to 2 times 3. Now here's the coolest part about this particular method. What we want to do is we want to look for, in order to find our GCF, the numbers that are in common, or the prime numbers in common. And I just want to take one per set of numbers, and they do have to be in common with all three terms in this particular case, or if you're working with 2, you want to have them in common with the 2 terms. So if we look at this, we notice that all 3 of our terms have a 2, so I'm going to write down 1, 2. I also notice that all 3 of our terms have a 5, so we're going to write down a 5. We are going to multiply these together to get our GCF, and 2 times 5 gives us 10. That is our greatest common factor between 7, 20, and 30. So for our next example, I wanted to do a problem where we actually have both variables as well as constant or numbers. So we're in this problem, we're going to find the greatest common factor, or GCF, between 3x squared y and 15x squared y. And we're going to work this exactly the same way as we did the problem before. So we're going to write out our terms, 3x squared y and 15x squared y. And 3 is already prime, so I'm just going to draw a line down and put a 3. I don't really need to prime factor him because he is a prime prime number. Now let's talk about the variables from x squared. So remember, when we see the squared, that means that we're multiplying something times itself. So x squared is the same thing as writing x times x. And what I want to do is just break them down because I want to look and see how many they have in common. And then we have a single y. 15 can be broken down. He is 3 times 5. Again, we have x squared, which is an x times x, and then we have another y. So now what we want to do again is we want to find that greatest common factor. We want to find the numbers and variables that both of these terms have in common. So very easily we can see that they both have a 3. So we're going to write down a 3. The other thing we can see that they have in common is they both have an x, but they actually both have 2 x's. So we're going to say that they have 2 x's in common, and they also both have that y as well. So we're going to say they have a y in common as well, and we bring that back together and we find out that our GCF is 3x squared y, and this would be our answer. So for our third example, we want to find the GCF between 5xy squared, 25x squared, and 10x cubed y squared. And this is very similar to the previous problem we did. We're just looking at 3 terms instead of just 2. So let's look. We have 5xy squared, 25x squared, and then 10x cubed y squared. And again, what we're going to do is take and break this problem down, each one into their prime numbers. Again, 5 is already prime, so we're not going to do anything to him. We have 1x and 2 y's. We'll do the same thing to 25. He is 5 times 5 with 2 x's, x times x. And 10 is 2 times 5. This time we have 3 x's. We have x cubed and then 2 y's. And again, what we want to do is the same thing we've done in the last 2 problems. We want to look at these broken down numbers and we want to see what particular numbers they have in common. So this one looks like they all have this 5 in common. So I'm going to highlight that, show that I have looked at that number. They also have just 1 x in common, and so they would have an x in common, and this is actually all they have in common. Now if you notice, the first term has 2 y's and the last term has 2 y's, but since the middle one doesn't have those y's, they can't be in common. Remember, the GCF has to be in common with all terms present, so if we have 3 terms, it has to be in common with all 3 of them, not just 2 of them. Okay, so for our last problem in this video, I wanted to look at a very specific problem. I want to still find the GCF. Haven't really changed what I'm doing, just a little bit different as far as what my answer is going to end up being. But I want to find the GCF between 21, 85, and 22. So again, just writing those numbers down: 21, 85, 22. And again, just like before in all the previous 3 problems we worked, we want to break down these numbers. So 21 is 3 times 7. 85, if you don't know what divides into 85, that's okay. Remember, it ends in a 5, so it's automatically divisible by 5, and it's actually 5 and 17. And then 22 is 2 and 11. Now when we start going and looking for that greatest common factor, notice that when we look at the numbers that each one of these guys breaks down to, they actually don't have any numbers in common. There's not a number that divides into 21, 85, and 22. But that's not exactly true. There is actually a number that divides into all of these numbers, and that number is the number 1. So right now our greatest common factor is 1. Okay, so terms always have a greatest common factor. If they don't have any actual numbers other than 1 in common, then 1 is their GCF. This doesn't matter whether it's numbers or variables. If you have multiple terms that have no numbers or no variables in common, their greatest common factor is automatically 1.